All right, hello everybody. Today we're going to talk about equilibrium in space, which really just means within the 3D environment. And as we saw in the 2D environment for equilibrium, what we said is our resultant force is equal to 0, or we can say the sum of the forces in the x and sum of the forces in the y. If we sum up our forces in each one of those directions, we end up with 0. Same idea with the z direction. So we're just adding one more component. All the problems that deal with this equilibrium in 3D tend to work out about the same way, and I think it would work out best if we saw an example. Okay, so in this example what we have is a hot air balloon, and it's tethered to the ground with these 3 different cables, and in this case we're trying to find the vertical force P exerted by the balloon based on the only thing that we know is the tension in cable AD is 481 newtons. If I were to look at a free body diagram of this, what we're saying is there's a force that the balloon is pulling up, which we are calling P. If you can really see that in there, it's kind of hidden. And then anytime I have a cable, my tension is going to be right along the cable. So this would be like my tension of cable AC. This would be my tension of cable AB. And cable AD we are given. So the tension in cable AD we are given as 481 newtons. So with that in mind, this is the general process that we are going to follow. So step 1, the first step in these types of problems, is to find the length of each vector, or in this case the length of each cable. So here what I'm saying is I have vector, or force, AB, and I can see that AB has an x, y, and z component, so I'm going to use this Pythagorean in 3D. And with cable AB, the first thing that I note is that when I go from A down to B for this x direction, kind of map it out, right? If I were to draw a little straight over and straight down. For this x direction, I can see I'm going 4.2 meters, but it's in the negative x direction. Now we're squaring it, so the sign doesn't really matter, but I like to put it in there anyways because that way I'll remind myself that it is in the negative x direction, which will matter when we're summing these things up together. In the y direction, I go down 5.6 meters, so a little 5.6 squared. And in the z direction, it doesn't go anywhere, so I have a 0 squared. Once again, the 0 doesn't affect anything. I'm putting in there for a placeholder to remind me that it doesn't go anywhere in that z direction. So if I do that math, I end up with 7.0 meters for cable AB, and I can follow the same process for cables AC and AD. Alright, so once I have the cable lengths figured out, what I'm going to do is put each one of these forces, these vectors, into their component form. So we'll call that step 2. So for AB, say tension AB, force of AB. Now, anytime you have a variable, meaning I don't know what the tension in AB is, I'm going to leave it just as TAB. And of course, to get its proportionality in the x direction, I'm going to multiply it by the magnitude, the distance in the x direction, this 4.2 over the hypotenuse 7. So all of that is in my I hat. And that's why I keep my sign in there. So what I'm doing is I'm just looking up here and I'm saying, all right, well, how far does this cable move in the x direction versus the hypotenuse? And that would be my I hat. Same idea with the j hat and k hat. So I'll fill those in for AB. Cool. So that's how cable AB would look. And now I'm going to do the same process for AC. Cable AC, also unknown, so I'm going to leave that as a variable. And once again for cable AD. Now the difference with AD is I do know the value, so I'm going to put in its value of 481. And same process now at AD, I look in the x direction, I see that it's 0, hypotenuse 6.5, so I just have 0 over 6.5. Of course that's going to be 0, but doing it for a placeholder. And so on and so forth for the other parts of components of TAD. Now, once I have those 3, I also want to include any external forces. In this case, I have one more. It's just a P or the magnitude of P pulling up on the balloon, you might have a cable that's along the X, Y, or Z axis, and the process is the same, where it's like 100% in that direction. So when I think about putting it into component form, that P is pulling 0 newtons in the X direction or I hat direction. Everything has to be in the J hat, so I'm going to have a positive P, J hat, and then I'm going to have the 0 in the K hat. So step 3 in this process is that we want to add up all of our components, or set the sum of all of our components and set them equal to 0. The way that I do this, now you could set up a matrix, and basically what you're going to have are 3 equations and 3 unknowns, because we can do sum of the forces x equals 0, sum of the forces y equals 0, sum of the forces z equals 0. Your 3 unknowns are TAB, TAC, and P in this case, right? Alternatively, what I see a lot of students do, or what I probably start off with, is strategically looking at it and saying, what can we solve for when we look at this X, Y, and Z direction? So what I'm really doing here is I'm saying, if I were to add up all of my I hats, right, all of my sum of the X directions, what I'd see is I have 2 unknowns, TAB and TAC. So I could do that, but I'd have one in terms of the other. And I may have to do that and do some crazy substitution. In the J hat, same idea, but I have 3 unknowns. It's even worse. But if I come over here to the K hat or Z direction, well, this TAB is 0. So all I have is 1 unknown, this TAC. So I can solve for that right away. So I'm going to start with this K hat direction. And if I do that, add up all my K hats, what I have is this TAB is 0. So I'm just going to drop that, and I have TAC times this 4.2 over 7.4, and then I have this plus 481 times minus 3.3 over 6.5, and set all of those equal to 0. If I do that, I can solve for the tension in cable AC, and I get a tension in cable AC is 430.26 newtons. Now, moving on, since I know TAC, I can go back to this X direction, my I hats, and since I know TAC now, I could solve for TAB. So the second one I would go to is my X, or my I hat direction. If I do that, I have TAB times this minus 4.2 over 7 plus TAC times 2.4 over 7.4 is equal to 0. And then I can sub in this TAC right there, and I can solve for my TAB. And I found a TAB to be 232.34 newtons. Alright, so the last step in the process, after we have our Z and our X direction taken care of, we can finally go on to this Y direction, which will provide what we're looking for with this unknown P. What I see is I have to include that P. I'm going to start with the P so I don't forget it. So that's a positive P plus TAB. Alright, and since I set the whole thing equal to 0, and all the other tensions, of course, are negative, pointing in the negative Y direction, I end up with a P value that is equal to 926 newtons, and that is up. Or we could also say it's the positive J hat direction. So I hope you found that useful, and I will talk to you soon. Thanks.